Okay, in this section right here, we're going to be starting our look into different types of quadrilaterals. Here's the first two in section 6.2. We're going to be looking at kites and trapezoids. You're going to want to write down all the different characteristics of these shapes that will help you answer questions as we move along. A kite is a quadrilateral with the following characteristics. So a kite is just like you may think about, just picture the old school kite types, the little shape right here. So let's run through all the different conditions or characteristics that we have. Some things to remember about a kite. Two pairs of adjacent sides are congruent. Okay, these two sides are congruent. These two sides are congruent. So two pairs of adjacent sides are congruent. One pair of opposite angles are congruent, and that's the obtuse one, which means these two angles, A and C, are going to be congruent. Not necessarily the top and the bottom one, but these two will be. Okay? The diagonals are perpendicular. The dotted lines here are the diagonals. They will form a 90-degree angle here in the middle. They are perpendicular. Not only that, but the long diagonal bisects the short diagonal. So the long diagonal is a perpendicular bisector of the short diagonal. The long diagonal bisects the pair of opposite angles. So these two angles are bisected by the long diagonal. This is not true with the short diagonal. These angles are not bisected, but these two angles, B and D, are. Okay? Because these sides are congruent, the short diagonal can break the kite up into two triangles, this one right here, ABC and ADC, and both of those triangles are isosceles because the legs are congruent. Whereas the long diagonal will cut the kite into two triangles, okay, and they are just congruent. Okay, they will be congruent to each other. And the last one is I can find the area of this kite, okay, by simply doing this. It is take the length of diagonal 1, times it to the length of diagonal 2, and then cut that value in half, and that will be the area of this shape. So there's a lot of properties here, a lot of characteristics of a kite. You want to kind of generally know as many of those as possible because that will help you then in answering any kind of questions that may come up from those. And for example, I'm going to show you some examples now. So here's an example. Here's a kite. What is the measurement of angle AXB? What is AXB? Okay, I want to know that. And when you do these things, you have all the reasons over here, and I want to know why you know what the angle is. So for angle A, part A, what is the measurement of angle AXB? AXB, well, it is 90 degrees. Why is it 90 degrees? Because one of the characteristics is that the diagonals are perpendicular to each other. Why is this true? The diagonals are perpendicular. That is one of the characteristics of a kite. What is the length of AC? So what is this length? Well, I know this length, A to X. So since AX is 3.8, I know what? I know the long diagonal will bisect the short diagonal. That means these two pieces are identical. So now I can say that AC is 2 times the length AX, which is 2 times 3.8. And then I can get my answer from that at 7.6. Why? The long diagonal bisects the short. The long diagonal bisects the shorter diagonal. Question C. BD is 10. Does that make BX 5? And the answer to that would be no. The short diagonal does not bisect the longer. Okay? So when you work some of these problems out, make sure not only you just give me the answer, but you also tell me a reason why using the characteristics of the shape that you're doing. Okay? So please make sure that you do that. Let's look at another example. Here is a quadrilateral. Quadrilateral, again, remember, means 4 sides, W, X, Y, Z. And I'm telling you it is a kite. So once I've told you it's a kite, I've told you all of these characteristics. All of these now are true. Okay? What is the measurement of angle 1, which is right here? And then we're going to find the measure of angle 2 from right here. So what is the measure of angle 1? Well, what characteristic do I know? I know that the diagonal, there's a lot of ways to answer this, by the way. I know that the diagonals are perpendicular to each other. Since they are perpendicular to each other, this is a right triangle. So I know this, okay? And so then I can find the measure of angle 1 because the measure of angle 1 plus this angle up here, which is at 32 degrees, has to be 90 degrees because the sum of the angles of a triangle is 180. So I know that that angle plus 32 plus 90 equals 180, or that this equals 90 degrees. Okay? And so that means then that the measure of angle 1 must be 58 degrees. And that came from the fact that the diagonals are perpendicular. That's how I got that information. What is part B? What is the measure angle 2? What is the measure angle 2? Well, what do I know? In a kite, the long diagonal will bisect the opposite angles. So that means this angle up here at X was bisected. So if that means that that is 32, then the measure of angle 2 is also 32 degrees. Because the long diagonal bisects opposite angles. That's why. Okay? Make sure you know your little rules there, because that will help you, like I said. Let's look at another problem for another shape, better yet. The shape is called the trapezoid. Okay? So here's the trapezoid. What is the characteristics of a trapezoid other than it's a quadrilateral? Well, a trapezoid has exactly one pair of opposite sides that are parallel. Those sides are then, from that point on, called the bases. So whatever sides are parallel, those are called the bases. The other ones are called legs. So since these are the parallel sides, these are bases, and these become legs. I know that each lower base angle is supplementary to the upper base angle on the same side. Well, think about it for a minute. If I drew this out and extended these lines, then this would be a parallel line, this will be a transversal, and these would be same side interior angles. So yes, they're going to be supplementary. So these two angles are supplementary, those two angles will be supplementary. Now, let's go beyond this trapezoid. There are special kinds of trapezoids, and the special properties associated with trapezoids that we want to know. And the first one is the trapezoid midsegment theorem. We had one for a triangle, now we have one for a trapezoid. And so here's how it works. Here's a line segment that connects the midpoints of the two legs. meaning this segment, this side is bisected at X and this side is bisected at Y. They are not, each piece over here is not the same. They are different lengths. But this I've drawn to the midpoint on both legs. That means all three of these segments will be parallel to each other. And the length of this segment right here is 1/2 of the sum of the length of the two bases. 1/2 the sum of the two bases. Okay? So this is a property that you can use to help you solve some certain problems out and stuff like that. Now, another type of trapezoid would be like a triangle, would be the isosceles trapezoid. So what is unique about that? The legs are congruent. So it's a trapezoid. So the bases are parallel. Consecutive interior angles are supplementary. These are called legs. In an isosceles trapezoid, the legs are congruent. So if my legs are congruent, then I know that the lower base angles will be congruent to each other. The upper base angles will be congruent to each other. And the diagonals will be congruent to each other. Okay? A lot of questions in the future deal with isosceles trapezoids and things like that, so you want to make sure that you know the characteristics and such. Okay? So let's look at some examples that deal with trapezoids, the mid-segment, the isosceles, and so on. So here's an example down here. I'm given an isosceles trapezoid, PQRS. What is the measure of angle P, Q, and S? If I tell you that this angle up here is 135. Okay? Well, if this is an isosceles trapezoid, then I know that this side length right here is parallel to that one. I know that this length is equal to that one, which makes the base angles down here congruent and this angle congruent to that angle. So that means the measure of angle Q must also be 135 degrees. Why? Because base angles are congruent, and these are base angles. What else do I know? I know that the measure of angle S plus the measure of angle R equals 180 degrees because consecutive are the same side interior angles are supplementary. And R is 135, so the measure of angle S plus 135 equals 180, which makes the angle measure of angle S to equal 45 degrees, which means not only S is, but so is P, because base angles are congruent. Okay? What about this one over here? I have given you that these two sides are parallel. I have given you that these two sides are congruent. That makes this trapezoid an isosceles trapezoid. I want to find this angle right here, TUR. Always identify what you're looking for. And I know that this angle out here, this exterior angle, is 47 degrees. So what do I know? Well, because this is 47, I know that it is supplementary with this side right here. So the measure of angle SRU plus 47 must be 180. So the measurement of angle SRU must be equal to 133 degrees. And so then by that alone, I've already established that this is an isosceles trapezoid. The measure of angle TUR is also 133 degrees because the base angles are congruent. And there's your reasoning for that. Okay. Let's look at this example. Given isosceles trapezoid MNOP. So I've now established that that is an isosceles trapezoid and all the characteristics are in play. These expressions right here are the length of the diagonals. So what is the measurement of, or what is the value of A? Well, in an isosceles trapezoid, the diagonals are congruent. So that sets up your equation. Since they are congruent, I know that A plus 13 must equal 2A minus 1. And then I can solve this for A. Move the A, move the 1, add the 1. And so 14 equals A. And so A is 14. Here's another one down here. By looking at the picture here, so I have given a trapezoid, JKLM. What is the length of KL? What is that length up there? When I look at this, I can see that I have a trapezoid. I see that XY is a segment connecting the midpoints on each leg. Because of that, tells me I'm at the midpoint here. So this is the midpoint, the mid segment theorem for the trapezoid. And so I want to find side lengths. All three of these are parallel. And so the rule says, according to with the letters that you see here, XY, the length of XY must be equal to 1/2 the sum of the lengths of the two bases. The sum of KL plus JM. That must be true. So then let's plug in what we know. We're trying to find KL. Do I know this? Yes, they gave it to me as 25. I don't know KL, that's what I'm looking for. Do I know JM? JM is that. So I can replace that in my equation. But I know XY. XY is 25. So now I have 25 equals 1/2 KL 4/5 times 25. Well, I can work that out. Okay. 5 into 25 is 5. 5 times 4 is 20. So I now have 25, 1/2 KL plus 20. So it gets a little bit simpler now. We can see this thing. You can do this a lot of different ways. You can distribute to 1/2 and then move things around. Or you can notice that I have 1/2 times a quantity. So I can remove the 1/2 by simply multiplying both sides by 2. If I multiply both sides of this equation by 2, I get this. And if that's this, then KL must be equal to 30. And there you go. Okay, so we'll be doing more problems together in the course of this lesson. So that ends this video.